This is the scenario interest applications. First of all, put your name in. All right, let's see here. We're going to calculate simple interest, parts of a year, compound interest, maturity value, ordinary and exact interest, distinguish between them, and then use an amortization schedule. So we're going to mostly just learn about how to use the Excel financial functions. If you want to watch the video, just click here. Alright, so we need to estimate how much interest would you have on $1,200 for 1 year at 10%, I don't know, say $100. Alright, let's see what we get here. Principal times rate times time. So we have principal is $1,200. The rate is 10%. And the time is 1 year. So the interest is the principal times the rate times the time is $120. Our future value is how much we loaned plus the amount of interest. Maturity value is add those two together. Alright, so now the interest on a $12,800 loan at 7% for 2.5 years. So our interest is principal times rate times time, and we get $2,240. Francis Koo is planning to start a business to export American foods to China. He says he needs $50,000 to pay for the organizational cost. Get samples and make 3 trips to Shanghai. He can borrow money from relatives for 3 years, and he's willing to pay them 10% ordinary simple interest. So, how much is the principal? $50,000. The rate is 10% for 3 years. So interest is principal times rate times time, and he will owe $15,000 in interest. So his total amount owed is the principal plus the interest, because he has to pay back the principal too. All right. Next one. $8 million, 9% for 90 days. Let's say about $100,000. Principal is $8 million. The rate is 0.09. 90 days. It says interest is the principal times the rate times the number of days divided by 365, because it says exact interest. Exact means that a year has 365 days. Next one. Now what's ordinary interest? Well, we take the 625 is still the principal. The rate is 0.081. The number of days is 60 days, and interest is principal times rate times 60 days, but since it's ordinary, it says the denominator is 360, so we get $8.45. The principal is $625. The rate is 0.081. The days is 60 days, and the interest is the principal times the rate times the time divided by 360 is $8.44. Okay, let's look at the next one. Charles Peterson managing partner of a local transportation company, thinks that the company should borrow money to upgrade its truck repair facilities. After investigating several sources of short-term loans, he determines that the company can borrow $250,000. 250,000 for 180 days at 7.5% interest. What will be the amount that he needs to repay in 180 days? So his interest is the principal times the rate times the number of days, and it says exact, so divided by 365. Okay, so for number 6, the principal is 250,000. The rate is 0.075. The days is 180 days. The interest is principal times rate times time, but then it says since it's exact, we're going to divide by 365. And we get $9,246.58. Next one. Oh, then how much does he have to pay back? Well, he's got to pay back the interest plus the principal. All right, next one. Steve Teeter took out a loan for $3,500 for 270 days. Interest, sorry about that. The interest was $269. The principal was $3,500 for 270 days. Ordinary. Well, the rate is the interest divided by the principal times the time, 270 days, divided by, since it's ordinary, it'll be divided by 360. And, we get 10.2% interest. Compound interest. Here we go. We're going to use the future value formula. Number of periods in a year. Well, since it's compounded quarterly, there's 4 of them. Nominal rate is 6%. Interest per period is the nominal rate divided by how many periods. In this case, 1.5%. Principal is $3,000. Maturity value. So use the formula equals future value of the rate, which is 1.5%. The number of periods is 4, and the present value is $3,000, and so we get $3,184.09. Now it's negative because we made the principal positive, but we could have done it the other way around. Interest is the $3,184.09 minus the $3,000 that we invested. And what? $3,184 minus the $3,000 that we invested. Oh, I didn't put in the equal sign. And we get 184.09. The effective rate is the amount of interest, which is $184, divided by the principal times the time. The time is 1 year, so it's just divided by the principal. How much will her investment be worth in 6 years? Well, there's 6 times 4 quarters in a year is 24 compoundings at 6%. So the interest per period is the 6% divided by 4 quarters. She still has $3,000 in the bank. Her maturity value is future value. Let's pull down the formula. It's the rate, 1.5%, for 24 periods at $3,000, and it will be $4,288.51. Two different things here. We've got a 6-year certificate and a at 4% quarterly and 5% annually. So there are four quarters in a year, but only one annual in a year. The nominal rate is 4%, and over here it's 5%. Interest rate per period is the 4% divided by 4 quarters. Here it would just be 5% since it's compounded annually. Number of periods, it's 6 years, so times the number of quarters, 4. And over here it's just 6 years. Principal is $8,000. Oops. And it's $8,000 here too. Maturity value, so equals future value, and we're going to do the rate is 1%. Number of periods is 24. Present value is $8,000. So we're going to have $10,157.90. Over here, future value will be rate 5%. Number of periods 6. Present value 8,000. So we end up with a little bit more money at 5%, even though it's only compounded annually. Loan amortization schedule. Oops, I got to show you that that's where we're going next. 13 through 15 is on the loan amortization schedule. Okay, so we know she put 20% down. We want to know how much she financed if she purchased it for 100%. Well, she financed it for 20% down means that she financed 80%. We want to know how much money that is if she paid $188,000 for the house. So our amount she financed is cross multiply. This times the 80% divided by the 100% means she financed $150,400. We put that into the loan amortization schedule. You can find the loan amortization schedule by going to New, Sample Templates, and there's loan amortization right there. Okay, but here's how the loan amortization looks. We're going to take our $150,400 at an annual interest rate of I missed a point here someplace. Where did I miss the point? Oh. 892.08. Let's do it that way. And I think that'll give us all the points that we need now. 34.65. We're still 0.35 points off. Looks like it's right here. Interest. Oops.